Hello everyone, my name is Kevin Kremans. I'm one of the co-founders of PI Propelligence and responsible for research and development of Stochos. In this presentation, I'm gonna talk about Stochos, which capabilities it has. So I want to start with talking about the technologies and then going into some of the use cases. So let's start. So I want to start with an introduction to Stochos and the technology. So first of all, I guess most of you have an idea how machine learning and AI works nowadays. In engineering and other, let's say, technical industries, we need data as well as large language models, for example, need them. So our data come from experiments, simulation, measurements. Yeah. So for example, you are changing geometries, you do a simulation for the FEM results and get the maximum deformation or stress. That would be the data. So geometry goes in, stress goes out. That is what we take to train our AI model. And basically you can use every physical data as long as it's numerical. You can take everything from your simulation or experiments. If you have trained a model on your data, then you can replace your expensive or time-consuming simulation or experiment with a machine learning model and ask for new results, giving a new geometry or new process parameters or whatever you like to predict, and you get your answer typically within seconds. So this allows you to do fast optimizations, sensitivity studies, and a lot of other things which would be otherwise too expensive. With Stochos, we provide, let's say, 4 different pillars of usage of AI. The first one is accelerate. So we have, let's say, one self-developed AI algorithm which allows us to basically model any numerical data, any shape of numerical data, any physics. And the main topic here is that we replace simulations or experiment. The next one is improve. This is about optimization and how to use AI as a co-pilot, for example, to develop new products or to do optimization, things like that. And then we have understand. So people typically say AI is a black box. So here we have methods for sensitivity analysis, which helps the user to understand what did the AI learn, what are the main parameters influencing my results, so to get a deeper understanding and compare it with your physical experience. And the last thing is scale. So how can you distribute and scale your AI models? One option would be to build web apps with it, which you can do, for example, automatically with Stochos, or building, let's say, or integrate AI models into workflows, stuff like that. So in this talk today, because I have not time to cover everything, I will focus on these 2 first pillars. So let's start with a technology overview. So very quick, I want to mention that one of the things which makes Stochos special is that we have developed all our algorithms mathematically by ourselves, so they are unique. So you won't find them anywhere else. And the core of our AI solution is called Deep Infinite Mixture of Gaussian Processes. So that is our one single AI algorithm which we can use for any kind of modeling task. One thing which makes it special is the probabilistic model. So that means you get always an uncertainty quantification of the model, which we think is very crucial if you want to use AI in production. So that means you always get confident estimation of the prediction, and then you can decide if this is a reliable result or not, or if you should go back to do a simulation or a validation experiment. With deterministic AI, like regular neural networks, for example, you won't get this. So there is like gambling. You get just a prediction, and you can't know if you can rely on it or not. Besides that, I don't go into the mathematical details. What is for you as a user interesting is it has no real settings where you need any AI expertise. So you just put in your data, press a button, get your model. It can handle any kind of numerical data. We are specialized on working well with small data. So typically you get already quite good results